what I'm really trying to ask is how do I think about atmospheric pressure? I want you to think about it a very specific way. And this is the right way to think about it. Atmospheric pressure is about the collisions of air molecules colliding with the walls of a container. Okay? So when I think about a collision, what I want you to have is that I want you to have an image. Check this out. So here's an image that I want you to think about. There's all these collisions. So when I'm thinking about collisions, these molecules are colliding with the walls of the container. And as they apply, what they do here is that they apply a force on all the walls of the container. It is these molecules that collide with the walls that creates atmospheric pressure, or creates pressure in this case. So as an example here of what do I mean by this here, you feel the atmosphere. You feel the atmospheric pressure acting on you by air molecules colliding with your skin. So how you feel atmospheric pressure is those guys colliding with you. That's what I mean. So when you think about pressure, I want you to think about collisions. Everything is about collisions. So to explain what atmospheric pressure does, I need two concepts now. Okay, I need two concepts. And here are the concepts. Concept one, gas pressure. And remember, the air molecules is a gas, right? Air is a gas. So the air molecules, so gas pressures always move from a high to a low pressure region. And so what I'm really talking about here is that I'm saying this. Imagine that I have a region of high pressure. So when I look at this, I'm going to say that this is a high pressure region. And then what happens next here is that I have a region of low pressure. So then this is a low pressure region. So what happens here is that when I say gas pressures always move from a high to a low pressure region, that means that the system will always move in what? In this direction. So when I look at this guy, it always goes in this direction right in here. Always. So the question is, why does this happen? And what you're going to find here is that really what's happening is that when I say high, high pressure, what you're really finding here is that you get a region of what? A region of high kinetic energy. Oh man, what did I do there? A region of high kinetic energy. And then what happens here is that right next to it, I then have a region of low kinetic energy. And because faster gases have higher speeds, more of the faster gas will go in that direction. So that means here, so when I'm looking at my system always moves like this. You're going to see it move from the high because the faster kinetic energy molecules are going to move in that direction. That's why high pressure always moves to a lower pressure region. And what you're going to find here is that there's going to be something that's pretty surprising here. And it goes like this, that the vast majority of the time, the high pressure is atmospheric pressure. So we know what the high pressure region is, right? We always know. So this is a given. So in other words, we know what the high pressure is, all the time. It's atmospheric pressure. So what we want to do, so the goal here, our goal is, how do I say this? I can't write that. That's garbage. How about if I just say this? So we have a goal. What's our goal? What caused the low pressure? What caused it? And what we're really asking is what parameter caused it, and the way we answer this thing, and the answer to this question is that we use the ideal gas law to tell us why.